All right, hello everyone. So welcome back to this channel. Okay, so it's good to have you back. And here we are now going to have the last part of the material that we have been solving, the exercises of elementary maths 1 of the Nnamdi Azikiwe University. That's math 101. Okay, so this is the last part of it. Okay, so it has about 15 questions, and we hope to finish that in this one section. All right, so let's see. Okay, so we begin with the first one. Okay, so it says that now the first set of questions, let me give you the analysis of it from 1 to around 5 is from series and sequences, and then number 6 and 7 is from inequalities, number 8, 9, 10, 11 is from complex numbers, and then from 12 down is from trigonometry. So this particular material is all encompassing. It covered all of the things that you saw in this course. Okay, so here now we are going to have, so the first question says, suppose that the first and the last term of a GP is a geometric progression, which you can also call exponential progression. Okay, so the first term and the last term is 7 and 4, 4, 8. So first term is 7. Let's use L for the last term is 4, 4, 8. Okay, respectively. And then the sum of the terms, that's if the sum of first n terms, you know, like we usually say, sum of the first n terms or the sum of the terms, since we have already been told the first and the last term. So the sum of the terms in the sequence is given as 889. So Sn is equal to 889. Okay, remember that we don't know n, so that's why I'm using Sn. That's sum of all the terms in the sequence. So it now says find the second term in the in the sequence. All right, so what are we expected to do? First of all is to note that the formula for getting any term of a GP is given this way. Tn is equal to A multiplied by R raised to the power of n minus 1, where our A is the first term, R is what we call the common ratio, and then n is the number of term you're looking for. So if you're looking for the second term, so your n will be 2. Okay, all right, so take note of this. Now there are about a number of things I would like you to see here. This is one of it. Then the second one is that when it comes for last terms, last term of a sequence can actually be represented as the Tn, whether it's in a GP or in an AP. So that means we can actually write the last term as AR raised to the power of n minus 1. Okay, look, so let's begin. And then the other one you would also like to see is the Sn. So the formula for Sn is given as A into Rn minus 1, okay, all over R minus 1. All right, so now of course you know there are two of them. When your R is less than, this one is when your R is greater than 1, and this one is if you turn it, 1 comes first, that's when your R is less than 1. Okay, so now but we are assuming that of course this can go, so let's go ahead and see what that will give us. Okay, so if this is true, we are going to begin with this one. So, or let's begin with this one. So from this second equation here, it means that it implies that our ARN minus 1 is equal to 448. So if we substitute our A as 7, we will get 7Rn minus 1 is equal to 448. So divide both sides by 7. you will get that r raised to power n minus 1 is equal to 448 over 7 is around 64. Okay, so now I'm going to do something here. From indices, you're going to see that this left hand side is actually the same thing as r to the power of n all over r. Okay, of course, r to the power of 1, and that is 64. And so from there we can get that r to the power of n is equal to 64r. Let's keep this as equation 1. Okay, now then come back here. From this other third expression, you can clearly see that our a into r raised to power n now minus 1. Remember that this other minus 1 is below, is not like a power here. So all over r minus 1. You know, in this case, the both of them are in the power of r. But when it comes to the sum, your minus 1 is just down this way. Okay, so this is the sum of the terms of that sequence. It should be equal to 889. Okay, so from here we'll also try to simplify, bring in our a, which is 7, and that is 7 raised to power n minus 1. Let me cross multiply now. Let r minus 1 come over here. So you have 889 into r minus 1. Beautiful. So at this time we can also divide again by 7. So if you divide through by 7, you are going to have r to the power of n minus 1 is equal to 7 should be able to divide this. It will give us around 1, carry 1 over here, that's 2, carry 4 over here, that's 7. So 127 into r minus 1. Now I want you to understand what I'm trying to do. I am using the information given, and then I'm trying as much as possible to simplify it to see what it can give me and if it can lead anywhere. So here I've gotten Rn being equal to this, and I'm seeing Rn here. So is it possible to also make Rn the subject and then equate the two equations? So let's try and see. So this is minus 1 equal to, if you open this bracket, you get 127r. This times this is minus 127 as well. Okay, so from here you can clearly see that Rn alone can actually be the subject, and is going to give us 127r. Now this coming over here will be plus 1, so minus 127 plus 1 will be minus 126. This is beautiful. So we can call that equation 2, and immediately we can see that equation 1 is Rn and equation 2 is Rn. So you can equate both sides. So, both equations. So equating equation 1 and 2 is going to give us 127r minus 126 should be equal to 64r, since both of them are the same. So their right hand side should be the same as well. So you now collect like terms, and so you have 27r. This coming here will be minus 64r is equal to this one over here will be 126. And then for you to know what we are doing here, for us to be able to get the T2, which is what they asked us to get, they said we should get T2. You discover that, remember, this is the formula here, and we already have our A, so we also have our N as 2, so we needed R, and that's why we are doing this effort that we are making here, right? So, and this is already helping us do that. So 127 minus 64 is going to be 63, R equal to 126, and immediately your R will emerge. If you divide both sides by 63, your R will be equal to 2. And you are almost done. So we can then come here and then look for our T2. Our T2 is then going to be equal to AR raised to power 2 minus 1. Okay? and our A is 7, our 2 is 2, our R is 2, then 2 minus 1 is 1. So you just have 7 times 2, and so our T2 is equal to 14. And that is the solution to that problem. All right, so we move on to the second one, which is number 2. All right, so number 2 says that, okay, that the sum of some terms of a GP is 315. Okay, so let's begin. Sn, which we just said is equal to A into Rn minus 1 all over R minus 1. They said that this Sn now is equal to 315. So let me remove this one on this side. Okay, so for this question, Sn is 315. What again? It says his first term is 5, A is 5. And what again? Common ratio, R is 2. So it says we should find the number of terms in and the last term. Okay, so from here, to get the number of terms means we should look for R. So we can, we should look for N, don't mind me. So we can substitute our A is 5 into R, which is 2 to the power of N minus 1 all over 2 minus 1 is equal to 315. Okay, so here we can quickly, if you subtract this, you get 1. So 1 will cross multiply, you will still get that 315. So you will have 5 into 2 raised to the power n minus 1 is equal to 315. So we divide both sides by 5 so we can clear this and allow our bracket to emerge. So that's going to be 2 to the power of n minus 1 is equal to 315 over 5 is going to give us, I think, 63, because 5 divided 300 is 60, divide 15 is 3. Yeah, that's correct. So that means our 2, or let me go up here, it means that our 2 to the power of n will be equal to minus 1 coming over here will give us 64. Wow, that's nice. And so we can get our n now by taking 64 to the base of 2, which will give us 2 to the power of 8. Okay, is it 8 or 6? 2 to the power of 6. Therefore, our n alone is equal to 6. So we have gotten our n. That's the first question, the number of terms. Then they now said we should find the last term. Remember I said that last term, okay, okay, yeah. So that means that the total number of terms summed was actually 6, and so the last term is going to be T6, and so you are going to have your T6 as AR raised to power 6 minus 1, which is 5. So we'll substitute A is 5 times R raised to, our R is 2 raised to the power of 5, and that's going to give us 5 times 32. 2 to the power of 5 is 32, and that is exactly equal to 160. Okay, so we've gotten our we've gotten our n. So from the question, our n is 6, and our T6, which is the last term, is 160. Okay, so we move over to exercise 3. Excuse me. Okay, so sorry about that small break. All right, so now we have for exercise 3. Okay, so let's go there. It says that we are given this geometric series. So this is a series 2 plus 3 over 2 plus 9 over 8 plus 27 over 32, and it continues in that pattern. So you know the difference between a series and a sequence. So a sequence is just you give a list using comma to differentiate, while a series is that it forms, you use addition sign like this to show it. So that's just the difference. Okay, so it says A, that we should find the sum to infinity of this series. Okay, so how do you do that? There is a formula. Sum to infinity is written of this form: S infinity, and is equal to A all over 1 minus R if your R is less than 1, or R minus 1 if your R is greater than 1. So first of all, let's look for our R. How do you get your R from a geometric progression? Just pick a term and divide by the previous term. That's all. So if I pick 3 over 2 and divide by the previous term is 2, so that's 2 over 1. So that's going to give me 3 over 2 times 1 over 2, which is equal to 3 over 4. So the what do you call it now? The common ratio for this series or sequence is 3 over 4, and you can see it. If you multiply this by 3 over 4, you will get 9 over 8, and if you multiply this by 3 over 4, you get 27 over 32, and so on. So that's correct, and that is less than 1, so we can make use of this formula. That means our sum to infinity is going to be A is 2, the first term, all over 1 minus 3 over 4. And that is going to give you 2 all over 1 minus 3 over 4 is 1 over 4. And then, of course, this 4 can come up here to multiply your 2. And so your answer is what? 8. Okay? So, and that is for number 3. All right? So, we go again to number 4. Okay? 4 says, okay, sorry, that's not the end of 3. Okay? So, 3 has 2 questions. So the first one asked for sum to infinity, and then the second one is asking for us to find the first n terms of this particular sequence. Okay, and to find that, all we need to do is to now substitute into the sum of first n terms, which is Sn, and we have said repeatedly that it is equal to A into the bracket of, okay, so you can see in this case your R is less than 1, so we are turning it this way. So it's going to be 1 minus R to power n all over 1 minus R. Okay, so previously the ones we had, you could see that your R was greater than 1. Here we got the first example, we got R as 2. Okay, so it was good that we used the formula, this, where is it? Yeah, where Rn comes first before 1. So, but in this case, it is clear. We can see that our R is 3 over 4, which is less than 1. So, we turn it the other way around. If not, you're going to get a negative value. That's why we do that, and it's not good. Okay, so let's go. So, we'll now substitute here. So, it means our Sn is going to be A, which is 2, into the bracket of 1 minus R is 3 over 4 raised to the power of n. So we raise this to the power of n. Let's close this with a block bracket, all over 1 minus 3 over 4. Okay, so what do we do next? So we try to simplify that. If you do this subtraction, you are going to have 2 into, let's still leave this the way it is and see what that is going to give us. 1 minus 3 over 4 raised to power of n. Then all over, if you subtract this, you get 1 over 4. So this 4 will come up now, and so we are going to have our Sn as If it comes up, it will multiply 2 to give us 8 into the bracket of 1 minus 3 all over 4 to the power of n, and then we close the bracket. So this is the possible point we can get to for the sum of the first n terms. Okay, so and it's not bad that we stop here because we do not know the n. Assuming it says the sum of the first 20 terms, then our n becomes 20. If we said first 5 terms, our n becomes 5. Okay, so that being said, so that is the end of 3ii or 3b. So but then there is also a third question on 3, so which is particularly the reason why they didn't give us any n. So you will see it here. So it says, what is the smallest number of terms if the sum to infinity minus the sum of first n terms is less than 0.1? Okay, so if the sum to infinity minus the sum of first n terms is less than 1, 0.1, they're asking us to find the smallest possible value of n. Okay, so let's see. What did we get as our sum to infinity? We got 8. All right, so let's bring that down here. And what did we get as our sum of first n terms? That is 8 into the bracket of 1 minus 3 over 4 power n. Okay, we close the bracket. So this should be less than 0.1. Okay, so we try to simplify what we have. First is that we can actually open this bracket, and if we do, we will have 8 minus, of course, 8 times this will give us 1, and then minus 8 times this is going to become plus. So you have plus 8 into the bracket of 3 over 4 all raised to the power of n as less than 0.1. Okay, so this 8 will take away this 8, and if that happens, we just have 8 into 3 over 4 to the power of n as being less than 0.1. Okay, so what can we do next? So we'll try to divide both sides by 8. Okay, so and you know that if you divide the inequality by positive, the sign remains the same, so nothing will change. So this is going to be 3 over 4 all raised to the power of n is less than 0.1 over 8. That's going to give us around, in fraction, you know 0.1 is the same thing as 1 over 10. So if you divide again by 8, that's going to be 1 over 80, and which is about 0.0125 in decimal. Okay, so and we can choose to also take this to decimal if we want, and that will be 0.75 to the power of n is less than this. Okay, so at this time, to get our n, what do? You take the log of both sides, and of course the log of this. Okay, so the log of this on both sides, the log of this one on this other side. So what happens is that the log will help us bring down the n that is forming just bond. Okay, so it will come down now. So you are going to get this. So you have log of 0.0125, and so our n alone will now be less than the log of 0. Okay, we can actually try to get these values, but I want us to do it at once so that we don't have to be doing approximations. So we can just do the approximation once. Okay, so this is divided by the log of 0.75, and if you do that division, you are going to get that our n is less than, I think is around 15.23. Okay, let me try that You can also do that yourself if you've got a calculator there. So you have log of 0, first of all, 1 over 80. Yeah, we are correct. So log of 0.0125 divided by log of 0.75. Yes, is 15.23 approximately. Right? So what that does for us is that okay, we can now determine the value of n, and we are told to get the minimum value that your n can take. Of course, your n should be a whole number, so it implies that our n is equal to 15. That's the minimum value it can take approximately. Assuming it was up to 15.5, then the minimum value can be maybe 16 approximately. So the answer for this is 15. All right. So we will now get to a new page to continue, and that's the end for exercise 3. So we go over to exercise 4 now. So the number 4 says that this is yet another series and sequence question. It says that we should find the number or numbers whose arithmetic mean is 39 and whose geometric mean is 15. Okay, so you have two numbers. Let the two numbers be x and y. So let the numbers be x and y. Okay, so we said that the arithmetic mean is 39. What is arithmetic mean? That if you sum the 2 and divide by 2, you will get 39. So the implication is that x plus y, if you cross multiply, is going to give you 78. Call this equation 1. The second point, their geometric mean is 15. How do you calculate geometric mean? Square root of x times y is equal to 15. That's how to deal with geometric mean. What that means is that if you take the square root to this side, it becomes square. So x times y is going to be the square of 15, which is 225. Call this equation 2. So we have two equations to solve, and how do we go about it? One is quadratic, the other is linear. So we can make this one that is linear, make one of the variables a subject and then substitute into equation 2. Okay, so let's try that. So from equation 1, from 1 now we can get, assume that I make y the subject, so I'll have y is equal to 78 minus x. So what will happen is that I will now substitute into equation 2, and if we do, we are going to have x times y now is 78 minus x is equal to 225. Right, so opening the bracket, you have 78x minus x squared is equal to 225, and then we can collect everything to one side of the equation. And so if we take since our x is negative, so if we take everything to this side, that's going to be x squared. This one coming over will become minus 78x, and then this is already here, so you have plus 225. Everything this side will now be what? 0. So you are solving now a quadratic equation. And then of course you are looking for two numbers that you will multiply to get 225, and when you add, you will get minus 78. And what are those two numbers? Let's look at 3 and 75. Of course, if you multiply 75 by 3, you will get 225. And then what sign will we put there? Minus, so that we will get minus 78. Okay, so that's going to be, remember, like I said, we open two brackets. So we have x minus 3, x minus 75. And that is equal to 0. So what that means is that our x is equal to 3 or 75 as the solution. And then to get our y, we'll just substitute into this equation here. So when our x is 3, if we put here, our y will be 75. And when our x is 75, our y will be 3. So x and y will just alternate values. And then you can check that if you pick 3 and 75, add them together and take their arithmetic mean, this is going to give you 78 over 2, which is 39. Very correct. So it gives you back that arithmetic mean that we were given originally. And then if you do the other one, geometric mean 3 times 75, that's going to give you square root of 225, which is actually 15. So the geometric mean of the two numbers is also 15 as was given. All right, so that is the solution to number 4. And so we journey to number 5 now. So number 5 is beautiful. It says a progression has a first term. So the first term a is 12, and it has a fifth term t5 is 8. And so it says find the sum of the first 20 terms if the progression is arithmetic. Okay, so they've told us that the progression is arithmetic. That means we are looking for Sn, or where our n in this case is 20. So but recall that our Sn for arithmetic progression is equal to n over 2 into the bracket of 2a plus n minus 1 times d. Wow, I still remember all of this. This is beautiful. Okay, so we just substitute. So our S20 is going to be 20 over 2, which is 10, into the bracket of a times a, which is 12 times 2, that's 24, plus our n is 20 minus 1, we have 19, times d, which is a common difference. Okay, so and we do not know our d, so we are going to pause here a little. Let's try to get our d. So how do we get our d? We can get our d using the t5. So the t5, remember by formula tn, let me write for tn first. Tn for arithmetic progression is a plus n minus 1 times d. Okay, so if we are talking about t5, then it's going to be a plus 4d, because you have 5 minus 1. And so what is our t5? 8. What is our a? 12 plus 4d. So we take this 12 to this side. That will give us minus 4 is equal to 4d. And so our d alone is minus 4 over 4, which is minus 1. So you will bring that minus 1 here now. And that is going to give you 10 into 24. 19 times minus 1 is minus 19. So this is going to be 10 multiplied by 24 minus 19, which is 5. Therefore, our S20 is equal to 50. And that is the solution for number 5. And so we are 1/3 into this particular section. That's the module 3. Okay, because I said there are 15 questions, and this is the conclusion for the questions on series and sequences. And so we are continuing now to number 6, which is on inequalities, like I said. And there they said we should solve for x in this equation. 3 into x minus 1 is less than or equal to 2 into x minus 3. Okay, and they decided to give some steps that will help you do that. First of all, we open the bracket, which is 3x minus 3 is less than or equal to 2x. 2 times this is minus 6. So they first said add 3 to both sides. So to do that, you are doing that to remove this minus 3. So, and if you add 3 to both sides, you will have 3x is less than or equal to 2x. If you add 3 here, this will reduce to minus 3. And then the next is that they said subtract 2x from both sides. They want 2x to come over here, and this is going to be if you subtract 2x here, you are going to have 3x minus 2x, which is x is less than. If you subtract 2x here, this one will go away, so you just have less than minus 3. And that is your solution for exercise 6. Exercise 6 is quite simple. Okay, so next is to look at 7. And like I think I mentioned, 7 is also on inequalities. So but this time around we have a little fraction inside that. So 3x minus 4 over 2 is greater than or equal to x plus 1 over 4 minus 1. Okay, so we have to solve this. So first of all, we need to gather the fraction on the right hand side, and that's going to be, so this one will come down the same way. Is greater or equal to, if you take LCM here, this over 1, so you have 4, and here is going to be 4 into 4 is 1, and then you have x plus 1, and 1 into 4 is 4. 4 times this will give us minus 4. Okay, so they also tried giving you steps to take, and of course that's the simplest thing to do. They said multiply through by 4. That's to clear the fractions. And so if you multiply here by 4 and multiply here by 4, so you will discover that this 4 will clear this, and then this one will clear this, but it will remain 2. So these 2 will multiply this one. So you are going to have, you are going to have 2 times 3x will be 6x. And then 2 times minus 4 will be minus 8. Is less than or equal to, your numerator here will now just be x minus 3. Because 1 minus 3 is 1 minus 4 is going to give us minus 3. Okay, all right, so from here you will now discover that we have, okay, so you can actually now take minus 8 to this side and then bring x over to this side. Okay, so but they decided to take it step by step. They said add 8 to both sides, so this will give us 6x. Now if you add 8 here, this 8 will disappear, and so this side will now be x. Minus 3 plus 8 will give us plus 5. Right, so let's try to finish up here. And then here you will now have, they now said subtract 5x. Is it 5x or x? Sorry. Subtract x from both sides so that this one can go. So you have 6x minus x is 5x is greater or equal to, if you remove x here, this will go, so you just have 5. And then finally, you will divide both sides by 5, and your x is greater or equal to 1. Although, from your material, the solution stopped here, so but then you should be able to provide this as well. Alright? So that's the end for number 7. And then we move over to number 8. And like I mentioned earlier, number 8 is the beginning of complex numbers. Okay, so it says if z is equal to 2 minus 3i, we should find z squared. Okay, so how do you get z squared? Just multiply z by itself, nothing else. So z squared is simply 2 minus 3i all squared, which is the same thing as 2 minus 3i multiplied by 2 minus 3i. So observe what is going to happen here. So 2 will multiply 2 to give us 4. 2 into minus 3i will give us minus 6i. Then minus 3i times 2 is also minus 6i. And minus 3i times minus 3i will give us plus 9i squared. Beautiful. So you will now try to simplify this. This is going to be 4. Here is going to be minus 12i. And then we know that I squared is equal to minus 1. So minus 1 times 9 will be minus 9. And so our z squared, let me write it here. Our z squared is equal to, of course, this is going to be minus 4 minus 9 will be minus 5, and then minus 12i. And that is our solution. Okay, so, and that concludes for number 8. And straight away we move over to number 9. And 9 says that Z1, that means they are giving us two complex numbers now, plus 8i, and that is your Z1. And then Z2 is given as 1 minus I. So the question says we should find the value of Z1 all over Z2. This is another beautiful complex number problem, and it's just asking you to divide. So, and to divide complex numbers is just to bring in what we call conjugate of complex numbers. So I have Z1 over Z2. That's going to be equal to, my Z1 is 2 plus 8i. All over Z2 is 1 minus I. So that is going to give me, so I would look for a way to get the conjugate, and the conjugate of any complex number is just to change the sign here to the opposite sign. So the conjugate of the denominator is 1 plus I. So I will use it to multiply both numerator and denominator. So see what we are going to have. So 2 times 1, of course you know brackets will come in here. So this way. So 2 times 1 is going to be 2. 2 times I will be 2i. Then 8i times 1 is going to give us 8i. And 8i times I will be 8i squared. All over. There is a way to multiply conjugates. You can see this denominator, they are conjugates of each other. And it also represents what we call difference of two squares. So just multiply, square one minus square the other one. So I squared. That's all. Okay? And we can continue here. Let's see. So let's collect like terms here. We have 2i plus 8i will give us 10i. I squared is minus 1 times 8 is minus 8. All over. This is 1. This is minus 1. And minus 1 minus... minus 1 will give us plus 1. And that's 2. Okay, so there we are then going to have... collect like terms here. 2 minus 8 is minus 6 plus 10i all over 2. And so these two will divide everything in the numerator. So you are going to have minus 3 plus 5i as your solution. Okay? Okay, so that's the solution for number 9. Alright, and I think that my board here is full, so we go to a new page. Right? And so we continue with number 10. Okay, so for number 10, we have Find the conjugate of z1 minus z2. Okay, so if z1 is equal to 2 plus 3i and z2 is equal to, that's what they gave, 5 plus 2i. Okay, so solution. First of all, you need to get your, meanwhile, note that this is how we write conjugate. This is z conjugate. So the meaning now is that my z1 minus z2 conjugate will be like this. Okay, so but first of all, we need to get our z1 minus z2, and that's going to be 2 plus 3i minus, you can put the second one in bracket, 5 plus 2i. Okay, so that's going to be 2 plus 3i, minus will come on this, it will be minus 5, minus will come on this, it will be minus 2i, and that is going to give us that our z1 minus z2 is equal to 2 minus 5 will be minus 3, and then 3i minus 2i is plus i. Okay, therefore the meaning is that our z1 minus z2 conjugate will be equal to, remember I said earlier on that it's just the sign, and the sign you're changing is the one between the real number and the imaginary number. So it's not this one. This one will still remain the same. So minus 3 will be there. So only this sign will change, and that's minus I. Okay, so this is your solution. Minus 3 minus I. Alright? And then we go over to the next, which is 11. 11 says, suppose 3 plus 5i all over 1 minus 2i is equal to a plus bi. We are to find a and b. Okay, so invariably here you have two complex numbers dividing, and they are only asking you to simplify this to be a single complex number, and then whatever is in the position of a is the value of a, whatever is in the position of b becomes the value of b. And like we did up the under division, you just take conjugate. So here we have 3 plus 5i will be multiplied by the conjugate of the denominator, which is 1 plus 2i, all over 1 minus 2i will also be multiplied by its conjugate. This is to balance it so that nothing will be misjudged or changed from what was originally given. Okay, so let's open our numerator. 3 times 1 is 3. 3 times 2i is 6i. 5i times 1 is 5i. And 5i times 2i is 10i squared. Permit me to put minus 1 here immediately because I squared is minus 1. And then for the denominator, 1 squared is 1 minus, here you have 2i. So you're squaring 2i, and that will give you 4i squared. Remember again, I squared is minus 1. Okay? So this is now going to give us, we will now have, of course, 3 minus 10. This will be minus 10. So it will be minus 7. And 6 plus 5 will give us 11i. All over, this one will be 1 plus 4, which is 5. Okay? So, what we have now is still in a fractional form, not of this form yet. So we'll now try to use 5 to divide the individual terms there. So that's going to be minus 7 over 5 plus 11 over 5i. So immediately it is of this form now. So the one that is without any I is your A. Therefore, or I can write that somewhere there. Therefore, my A is equal to minus 7 over 5, while my B is equal to 11 all over 5. And that is the solution to that problem. Okay, and I think that brings to an end the questions we have under complex numbers, right? So we did 5 questions in series and sequences, and we did about 3 or 2 in inequalities. So now this one started from 8, 8, 9, and then 10, 11, 4 questions on complex numbers. So the remaining 4, that's 12, 13, 14, 15, are from trigonometry. Okay, so let's see quickly how fast we can go with that. Okay, so the first question says, show that, that's number 12 now. It says, show that sine 2a all over 1 plus cos 2a is equal to tan of a. Wow. Okay, so is a derivation that we are going to do here. So one thing you must know about trigonometry is that you must be good with trigonometric identities, and there are the basic identities you should not joke with. First is that you must know that hypotenuse squared is equal to opposite squared plus adjacent squared. This is the beginning of trigonometry, okay? And of course, it's coming from a right angle triangle where the side facing the right angle is hypotenuse. Let's say here is opposite, the other one is adjacent, okay? So, and then we have this. So this is called the Pythagoras theorem. It's very important, okay? And so from there, you will now begin to progress where you know SOHCAHTOA. You know that sine of an angle is equal to opposite over hypotenuse. The cosine is equal to adjacent over hypotenuse. And the tangent is equal to opposite over adjacent. That is SOHCAHTOA. Alright? So after SOHCAHTOA, you should be able to know other small ones, such as the sine of any angle all over cos of the angle is equal to tan. So you should know this one also. And you should also know that the sine squared of an angle plus the cos squared of the same angle is equal to 1. All of these are provables, okay? Yeah, you can actually derive this from here. You can also derive this from this same one. That's why I told you that it is the basics of trigonometry, and so you should know all of this. And then many other trigonometric identities all rise from these 4, okay? So if I divide through this one by sine squared, I'm going to get another identity, and so on and so forth. So that's just to tell you that this identity is just a derivation of this. And then there's also another one that is important, what we call the compound angles. And I'm going to just write for sine and cosine for the sake of this question. We are told that if you have sine of A plus B, that it is equal to sine of A times cos of B, then plus sine of B times cos of A. Now, if it is minus that you have here, here will also change to minus. And then, what about that of cosine? If you have the cos of A plus B is equal to the cos of A times the cos of B minus the sine of A times the sine of B. Okay? So if this one is minus, then here will be then here is going to be plus. So just take note of that. So like I said, for the sake of this question, these identities will be enough for us. So let's go. So from here you can clearly see that my sine 2a, remember, in showing that something is equal to another, you can keep this one. So you just pick this and show that it is equal to this. So and that's what we want to do. So my sine 2a is the same thing as sine of a plus a. So immediately you can see that it will work with these compound angles here. So, and that's going to give us sine a plus a will be sine of a cos of a plus sine, in this case your b is equal to a, that's what it means. So this will also be sine of a times cos of a, and you can see they are the same, so you can join them together to get 2 of sine a cos of a, and that is the hint they gave you there. So I am showing you how that was gotten. So they told you there that sine 2a is equal to this. So I've just shown you how that was derived. Okay? And then there's something else they wrote in the denominator, and I want you to see how. And what is that? You have cos 2a there. So cos 2a is the same thing as cos a plus a. And if you follow the other formula below, that's going to give you cos of a. Here your b is also a. So it will be cos of a cos a minus sine of a sine a as well. Right? And that is going to be, if you join these two, you will have cos square of a minus sine squared of a as well. So that's how they got the hint they gave us here. That's where they said that this our sine 2a all over 1 plus cos 2a, which is what we want to show is equal to tan. They said it is equal to 2 sine a cos a all over 1 plus cos squared a minus sine squared a. So this was the hint they gave you, and I've shown you how they got that. The numerator is this, the denominator, this one changed to this, and that's all. Alright? So it's now our duty. Of course, they said we should now complete it from here. So how do we complete it? So now come back to this one here. That's this particular relation or identity. You can see that if I make cos squared the subject there, I'm going to get that cos squared theta will be 1 minus sine squared theta. So why am I interested in cos? Because from what I wrote here up, I said that sine over cos is tan. So I want my sine to remain up. But if there is a way I can cancel out this cos and then get cos below, that will really help me. So watch what is going to happen. We are going to have sine 2 sine a cos a all over. Remember we just said now that if we join this guy and this minus sine squared a, that it is equal to cos squared. So that means that is going to give me cos squared a plus these two now will become another cos squared. That's this. Okay, so if you join the two of them, that will give you another cos squared a. Beautiful. And so see what you would get there now. So invariably, the denominator, let me even write it here. So the numerator is still 2 sine a cos a all over. So the denominator will now become 2 again, 2 cos square a if you join the 2. And immediately 2 will cancel 2. Follow me. Cos a up will cancel 1 cos a down. So you just have sine a up all over cos 1 cos a down. And you are done. We are told that this is equal to the tan of a. And so we have achieved what we are required to show, that is equal to the tan of a. So that is the solution for number 12. So you will notice that if you are to write it, you don't necessarily have to show this, because they've already told you that using this equation. So just go ahead and use the hint. I'm only showing you so that you will know, you have the knowledge, not that you are just solving exercises. So you can use the knowledge somewhere else, be it exam or quiz or wherever. Alright, so we go to number 13. And number 13 says that if tan theta is equal to 3 over 4 and theta is acute. You know the meaning of acute angle. An angle that is less than 90 degrees. Okay, it says then what is the value of sine theta? So this is a very tricky question, and it's very straightforward and simple. All they need you to do is just represent that information on a triangle. Remember, I just told you that all these hypotenuse, whatever is coming from a triangle. So let's assume that this is that theta, which is acute. So the side facing, remember that tan is equal to opposite over adjacent. So the side facing the angle is your opposite. So here is 3. The one below is now your adjacent. So here is 4. So it means that h is missing. And they are asking us to find sine theta, which is equal to opposite over hypotenuse. I know the opposite as 3. I only need the hypotenuse. And from Pythagoras theorem, which says that h squared is equal to 0 squared plus a squared. So what is O now? O is opposite, 3 squared plus a, which is 4 squared. So this will give me 9 plus 16, which is 25. So my h alone is going to be the square root of 25, which is equal to 5. Therefore, my sine theta is going to be equal to opposite, which is 3, all over hypotenuse, which is 5. And so my answer is 3 all over 5. These concepts are very beautiful. I wouldn't want you to walk in any form of confusion. So, and that's why I'm taking time to give you these explanations. Alright? So we go to number 14. So number 14 happens to be a technical one. It says if sine theta is equal to a squared minus 1 all over a squared plus 1, then we should find then what is the value of the said sec theta plus tan theta. So what is sec theta? Sec is 1 over cos. Okay, now this question is actually requiring that you do the same thing we just did here. So you will just kind of draw a triangle. So since you have your, let's assume here is still your theta, so sine is opposite over hypotenuse. So that means here will be a squared minus 1, and here is going to be a squared plus 1. So we need to get the adjacent. Alright? And immediately if we get the adjacent, remember I said that this one is 1 over cos. And you know that cos theta is adjacent over hypotenuse. So that means sec is going to be hypotenuse over adjacent, while, okay, let me write it in front. So this is going to be equal to hypotenuse over adjacent. That's 1 over, meaning turning it upside down, plus your tangent is going to be opposite over adjacent. So you see, for the two of them, we need to get the adjacent. So let's quickly do that. From the formula I gave earlier, h squared equal to o squared plus a squared. So here our h is a squared plus 1. So all squared equal to o is a squared minus 1. All squared equal to a squared now. So let's try to open these brackets. If we do that, we are going to have a squared times a squared is a to the power of 4. A squared times 1 is a squared. I hope you understand what I'm doing. I'm just opening this bracket this way. Okay, so a squared times a squared is a4. A squared times 1 is a squared. Then 1 times a squared is a squared. And 1 times 1 is 1. Equal to, on this other side, we will do the same thing. So there we are going to have minus minus. So a squared times a squared will be a4. A squared times minus 1 will be minus a squared. And minus 1 times a squared will be minus a squared. And minus 1 times minus 1 will be 1. Okay. Sorry. Remember that this thing here is plus a squared. Not, I don't know what I was writing there. Minus. I'll be equal to. It should be plus a squared. Okay. So we will now try to transfer all this to this side, or even from here you can clearly see that this one will cancel this. All right, so 1 will also cancel 1. So these ones, their signs are opposite, so let's join them. This will give us plus 2a squared. All right, while this side will now be minus 2a squared plus this other a is capital A, which is our adjacent. So if you bring this over to this side, it will become plus. So 2a squared plus 2a squared will give us 4a squared equal to a squared. And then if you now take this square to this side, that's going to give us that our a adjacent alone will be equal to the square root of 4a squared. And that is going to be 2a. Wow, this is beautiful. And you are done. So bring it into what we have here. So I'm going to bring down that sec theta plus tan theta. So remember we said that your sec theta is h over a and your tan theta is o over a. Alright, so you can easily even take LCM here. If you take LCM, you have a and here will be h plus o. So we can just substitute into that one. And that is going to give us, what is h? H is a squared plus 1. And what is o? O is a squared, we are adding it, a squared minus 1. All over what is a now, which is adjacent, we just got it as 2a. And that will complete this task. What is that going to give us? This a squared plus a squared will give you 2a squared. Then 1 will cancel 1 here. And so that is all over 2a. So 2 will cancel 2. A will cancel 1a. Your final answer here is a. That is beautiful. So your sec squared plus tan squared semian squared. Your sec theta plus tan theta is equal to a. Alright, and that is for 14. And ladies and gentlemen, we are finally on the last exercise of this material. And it says, that's number 15. It says, if alpha and beta are acute angles, okay, such that sine alpha is equal to 8 over 17 and cos beta is equal to 3 over 5. Okay, we are asked to find, without using tables, the cos of alpha plus beta. This is a technical question, I must say. Alright, so it says we should find the cos of alpha plus beta. Alright, this is important. They just gave you sine of alpha, they didn't give you sine of beta. And they gave you cos of beta, they didn't give you cos of alpha. And they know that you will need it. Let me show you. From where we talked about compound angles, I told you that the cos of A plus B is equal to something. And that's actually what they expect you to use here. The cos of alpha plus beta is going to be equal to the cos of alpha times the cos of beta minus the sine of alpha times the sine of beta. So have you seen now that you need cos alpha and you need sine beta? So you need to get those two. Alright, so how do we get that? We'll try to use our triangle again. So let's draw it. I sketch this diagram, this triangle. You gave me sine. Let's assume that this is my alpha here. And you said that sine is 8 over 17. Remember that 8 is your opposite. 17 is your hypotenuse. So here is 8, here is 17. So I need to get the adjacent, which is going to be by Pythagoras theorem. So adjacent squared is going to be hypotenuse squared, which is 17 squared minus 8 squared. So 17 squared is around 289. 8 squared is 64. And if you subtract, you are going to get 225. So our A alone will be the square root of 225, which is 15. So our adjacent is 15. So from here, I can actually get the cos of alpha. So what it means is that my cos of alpha is going to be adjacent, which is 15, all over hypotenuse, which is 17. So I've gotten this one. Now I'm going to come back here. I want to remove this. Permit me to do so. Let me remove this, okay, because I don't want to get to another page. That is why. So I just want us to do this here. Okay, now let's now go to beta. So what if we are talking about beta now and we are given cos beta? So beta cos is adjacent over hypotenuse. So that means 3 is the adjacent. Here will be the opposite. The angle or the side facing the angle. So the hypotenuse will be 5 and then the adjacent will be 3. So we are looking for opposites now. Opposite squared will also be hypotenuse squared minus adjacent squared. So you will have 25 minus 9, which is 16. So O squared is 16, and so our O alone will be 16, the square root of 16, which is 4. By implication, this point now is equal to 4. Okay? Alright, ladies and gentlemen, with that we have the value of our sine beta. Okay? So our sine beta, which is opposite over adjacent, over hypotenuse, our opposite is 4, and our hypotenuse is 5. Okay, I didn't even cross this. Okay, so now we can now substitute. Okay, so that means that our cos alpha plus beta is going to be equal to, what is cos alpha? We just got it as 15 over 17 multiplied by what is cos beta? We were given that one, 3 over 5. Then minus, close this in brackets, open another bracket. So here we will have sine alpha, we were given that 8 over 17 multiplied by the sine of beta, we got that 4 over 5, and then we are done. Once we simplify this, that will give us the solution. And so we'll try to see if we can cancel anything. 5 can remove 15 here, reduce it to 3. Okay, this cannot cancel, so you just multiply out 9 over 17 minus, here, can anything cancel out? No. So we just have 8 times 4 is 32 all over 17 times 5 is around 85. If I am correct, yes, 85. Alright, so to simplify this, finally we take LCM, which is 85. 17 into 85 is 5. 5 times 9 is 45. Minus 85 into 85 is 1. 1 times 32 is 32. So here you have 45 minus 32, and that will give you 1/3 all over 85. And that is the last solution in this exercise. I think I demand a round of applause, ladies and gentlemen. And that brings us to the close of or closure of this exercise that we began some days ago. So that is 15 to 14 to 12, 13 to 11 to 10, and then back here 9 to 8 to 7 to 6 to 5, and then to 4, and then back again you have 3 down to 2, and finally to 1. And that is for module 3 for the Maths 101 exercises. And so, ladies and gentlemen, this is where we draw the curtain for this exercise. And do have a pleasant semester as you continue in your study, and then we'll see you in other contents. Consider subscribing to our channel and do share it to your friends and colleagues. We'll see you in other videos. Bye. Oh my goodness.